So, okay, I welcome you to the video where we are to discuss important things about IPv4 addressing. So, let's start. Like first is again to take note that we have two versions of IP address, IP version 4 and IP version 6. Okay. Like with so this is the agenda of this video is for the IPv4 addressing. So first is that an IPv4 it ranges from 0 to 255. There's no 256, 257. Okay. Another that the total bits is 32. Okay, and its format is in 4 dotted decimal. Okay. So for example, say I have 192.168.10.1. Okay. Uh, so let me just add the one there. Okay. Uh, in uh, this number, say I have 192.168.10 uh, 10.1. Okay, there is a part there that represents the network part, and there is a part that represents the host part. So usually we have two parts in the IPv4. So and that is the network and host part. Okay, so I'll just place this here lower. So by definition, network part is the identity of the group. Okay, it represents the group, identity of the group. And the rule, it should be same. Then while the host part is the unique identity of the device, unique identity of the device, and this should be different. Okay, so again, yeah, take note of these two parts, network part and then the host part. So for example, I have this IP address here, 192.168.10.1. Okay, I'll just adjust it again. So let's say this 192 is a network part. So as with the 168 and the 10, while the 1 is the host part. Okay, uh, say I have this simple diagram here. Okay, so let's say I will assign the 192.168.10.1 to PC0 192.168.10.1. Okay, so again I have assigned this IP address to PC0. If I were to assign an IP add to PC1, the network part, this should be same. Okay, I'll just make it in center. Okay, there. So, if I were to assign IP add to PC1, it should be 192.168, sorry, 192.168.10. Okay, 10. And then host part should be different, say 2. Okay, so there. So IP add here should be 192.168.10.2. Okay, and if you were to assign an IP add to PC2, you have to observe the rule. So this should be same and say this should be 3 there. Okay? So that's how it is. Okay? If you did not observe this rule, eh, uh, it will not connect. Okay? You will not have any connectivity. That's why we are discussing this and very important to observe this rule. Okay? So next is uh, an IP address usually has a pair we call as a subnet mask. Subnet mask. Subnet mask by definition is the one that identifies which part in the IP address is the I'll just put it here is the network and host part. Okay, and host part. And the rule is uh, and the rule is so this is where we are to apply the conversion binary to decimal. So if it is 1 in bits, that is a network part. Okay, and if it is 0 in bits, it's a host part. Okay, so uh, let's have a demonstration here. So for example, like in this case, ano, I have this IP address 192.168.10.1, and we say that this is a network part, so as the 168 and then the 10, and then the 1 is the host part. Okay, so again, this is the our IP address. So if we were to uh, look into its, if we were to consider its um, subnet mask, subnet mask by the concept we mentioned. Okay, I'll just use SM for the subnet mask. Okay, so um, in binary, these are you have 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8 there. Okay, so as with the 168. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 8 ones. This is in binary, and 8 ones in binary is 255 in decimal. Okay, and what we usually and what we type in our end device is in decimal format. So this is 255, and 8 once again is 255. Okay, again I wrote ones here because again 1 in bits is network part. Okay, so in here still this is a network part. So its subnet mask in binary are 8 ones. 1, 2, 3, 4, 5, 6, 7, 8, and that is in decimal 255. While here the last one, this is a host part that is 0 in bits. So you have here 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. In decimal, that is 0. There, that's the subnet mask. In a given network, okay, um, they usually have uh, same subnet mask. Let's try to assign our address here. We go to the desktop and then ipconfig. So let's say I will assign 192.168.10. This is, let's follow the sorry, let's follow the uh, wait, let's, okay, this is PC2, so 10.3. So 192.168.10.3. Our subnet mask is 255.255.0. So I go here and then assign. So let's say 192.168.10.1. Again yan, same subnet mask it should be. And then as for the last one, desktop, IP add, and then 192.168.10.2. Okay? So, if you notice, if I were to uh, go to command prompt to check, we use ping. So I'll ping the other PC 192.168.10.1, and there's a reply, so meaning they're connecting. Okay? So for example, let's say I'll go back to the IP config, and if you notice, for example, I did not observe what we have discussed. I make this 11. Okay, 11.2. Let's try to ping, enter. And if you notice, it's not working. Because we abide with the rule that the network part should be same. Okay, so that's how it is. Next, subnet mask. I'll write here. Okay, I'll just have border. Saan yung border? Eto. Yan. So next is subnet mask can be presented in prefix. Okay. Subnet mask in prefix. Okay. So for example, say we usually say represent subnet mask example in sorry, as say /24. Okay, /24. No, and this is /24. Uh, the 24 means there are 24 network bits. Okay, there are 24 network bits. Like this one, right? We have 8 ones here. These are our network bits there, network parts. So 8, 16, 24. So meaning if you see a /24, oh, sorry. If you see a /24, it means in 4 dotted decimal, that is equivalent to that is equivalent to 255.255.255.0. Okay? That's how it is. Okay? Oh, again, let's have an example. Say example slash 16. So, sorry, slash 16. So if you have a slash 16, if you notice, maybe you notice I'm adding a comma here. It's only in Excel, so in a way, it will only display the slash, ha? The that comma ba tawag dito? Sorry, the single quote. The single quote. If you see the single quote, it has nothing to do with our discussion, okay? So, if you have slash 16, so, again, 16 ones, right? So, you only have 16 ones. Ito, 16 ones yan, di ba? 8 at saka 16. So, in 4 dotted decimal, that is equal to 255.255.0.0. Okay? And then say if you have, say, slash 8. Okay? Slash 8, that is equivalent to 255.0.0.0. Okay? There. Wait. I forgot the single quote. There. Okay? Very important this part here. Okay? Subnet mask presented in prefix. Okay? So, uh, next is, hmm, I'll go back here first. Okay. I'll continue. I'll move on to the next topic, and that is IP address class. IP address class. Okay. IP address, IPv4 address specifically, it's regulated by uh, ICANN and IANA. These are organizations in US. They're the ones holding the IPv4 and even IPv6 address. And uh, and one means for them to manage the IP version 4 addresses, they came up with classes. Okay, and we have 5 classes of IP address. Okay, so that's class A, B, C, D, this is C, class C, D, and E. So there are IP addresses out there that are of class A. There are those that are of class B and C, D, and E. Okay? Uh, there. So how would you know? You would know based on the first octet. First octet is first number. Okay, so you look at the first number for you to know the class. So if the first number is 0 to 127, so that is A. If it is 128 to 191, it's class B. 192 to 223 is class C. 224 to 239 is class D. And 240 to 255 is class E. Okay? So there. So let's have a sample exercise here on this side. Say for example, let's say I have an IP address of 13.1.2.1. So what class is this? So we have to look at the first number, that's 13, right? So 13 is in the range of 0 to 127. Therefore, this is a class A. Okay? So let's say if I have 225.3, the 2.3.4. So, what class is this? So, that's 225. That is in the range of 224 to 239. So, that's a class D. So, let's say I have 195.1.2.1. So, what class is this? You have to look again on the first number, which is 195. And 195 is in the class C range, right? Oops, sorry. 195 is in the class C range. So, that is a class C there. Okay. Uh, you know what? What we see out, what we see in our devices and in the internet are only within the ABC range. Okay. These class D and class E are uh, special. Okay. Class D is usually used. These are used for multicast, multicasting. You will learn about multicast more on Cisco 2. And then class E is for research. Okay. Very important here is the arrangement of the network and host part. So for class A, the first number is the network, while the last three are the host part. For class B, first two numbers are network, last two are the host part. And for class C, the first three numbers are the network and the last number is the host part. So that's how it is. Okay? So, I'll just make it in center. So now, um, here, based on what I mentioned here, so let's find out the default subnet mask. So if you notice, yung first number is network part, diba? And we mentioned that in each number there are 8 bits, right? So how many network bits do I have? If you say 8, that is correct. Again, each number has 8 bits, right? Oh, let's go back here. Yan no, each number in terms of binary, 8 bits. So therefore, this subnet mask here in prefix is /8. Okay? Here, there are two network part here. Take note, subnet mask, the way we define. Say if I have the number here, say /24, that 24, that's the number of network bits. Okay, that's what I'm doing here. So in here, I have two network part there, and each numbers or part there's 8 bits. So in this case, 8 network bits. So 8, 16 slash 16. And then for the last one, I have 3 network part. So /24. Okay, there. Uh, so, okay. Next. Okay, next. Say let's look at the sequence of the IP version 4 address. Okay, I need a new sheet. No, for example, let's say I have an IP address of 192.168.10. Say that's 0. I'll make this a 0. So again, what class is this? Based on the first number, let's take a look. 192. 192 is class C. Okay? So this is a C. And in class C, we said that the arrangement is network, 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 and host. So meaning the first number here, the 192 is a network part, the 168 is a network, the 10 is a network also, and then the 0 is the host part. Observing the first concept we've discussed, yung network part should be same, right? Should be same. So in a given network, the network parts are all the same. The first three numbers in class C, like in this case in class C, are all same. So we can only manipulate the last number, right? The last octet. So, and we said that the range is from 0 up to 255, right? So in a class C, these are the only range of IP addresses that we have. In a given network, there are around 250, like in this case, like around 256, 256 IP addresses for a class C. Okay? Oh, so that's how it is, no? So my point here is that in this class is the size of the network or the number of IP addresses that we have, it varies for each class. Like in class C, you only have like around 256. In class B, there are more. In class A, there are even more because usually if you notice yung host part, that's the only number we manipulate. And in class A, there are more host part. In class like 3, right? In class B, you only have 2, and then in class you only have 1. For us to know exactly the number of hosts per network in each of the given class, there is this formula. Okay, I'll write it here. Here. So the formula is that the number of hosts per network is equal to 2 raised to m raised to m minus 2. Okay? 2 raised to m minus 2. There. I suppose you know what this means. It means exponent. Okay? That's 2 raised to m minus 2. Okay? Uh, I'm okay with that. Where m is the number of host bits. Okay? So, I'll, I want to have some color in this space. I'll use this one. Okay, so we have this working formula. So let's have another table here. So for example, so we are to find out the number of, we need to find out the number of hosts per network for each class. Okay, number of hosts per network. And its basis is on the number of host bits, if you notice. Number of host bits. Okay, there. Okay, number of host bits. I'll have some borders for us to easily see what's going on. Okay, I'll just add some borders here. Give me some like 10 seconds. Like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There. Okay? So, number of host bits. Okay? So, how many host bits do we have in A? If you notice, diba, there's 3 here. 8 bits to, diba? Tigi 8 yan. 8, 16, 24. So, for class A, if we were to find the number of hosts per network, the M for class A, M is equal to 24. Okay? M is equal to 24. So, using this formula, number of hosts per network, applying the formula, so that is 2 raised to 24 minus 2. And if you were to compute that, that is around 16,777,214. Ay, nawala. Undo. Dito na nga lang. Hindi. Gusto ko ituloy eh. So, equal to 16,777,214 hosts. Okay? That's how it is. That's the number of hosts uh, for class A. That's too many, right? So example, in internet, example 1.0.0.0, UK has that IP address, a class A. So there are around 16 millions of IP addresses that are there in the class A IP address. So for B, M is equal to 16, right? So look at this. There are two host each H, that H has 8 host bits, and then we have another here. So that's another 8 host bits. So in total is 16. And applying the formula, we have 2 raised to 16, and 2 raised to 16 minus 2 is around 65,534. Okay, hosts. So there, I'll just input it here. So again, we have 24 host bits for A, and the number of hosts per network is 16,777,214. Here, we have around 16, and in here, so our computation is 65,534. And then the last is for C. So how many host bits do we have at C? M is the host bits. We go here and look. So we only have 1 and 8 bits, right? 8 host bits yan. So C now has an M of 8. Okay? Applying the formula, Control C, go here. So that's 2 raised to 8 minus 2, and there are 254 hosts. Okay, there. So this is 8. So and we have 254 hosts. Okay, so this is very important. Okay, nowadays we actually do not care about the class. Okay, we call it as already as a classless addressing. That's because of the subnetting, where we are to discuss that in the next video. Okay, but again, this IP address class is still very important uh, because we deal with routing, sample with RIP, and it deals with classes. Another, uh, it may appear still in the certification exam, so it's very important that you know very well about this IP address class. Okay, so I'm done with this part. I'll move on to my next board. Okay, so I'll go down now, and this time we will cover IP address type. There are IPv4 address type. And so an IP ad may be it may be classified, okay, a classification or a type. It may be classified as a network address, okay, it may be classified as a network address or a broadcast address, or a host address. Okay? There. So we call this as the IP address type or class. Okay? But very important is you know very well that there's a network broadcast, and a host address. Okay? Usually, example let's consider my range of IP address here. Again, the sequence is very important and this is how it looks like. So, uh, so I have here a class C, right? So you know what? The first one, this one, let's put some color. This is a network address. The first one is the network address. Okay, network address. The last one, we call that as a broadcast. I think we mentioned broadcast in our previous discussion. Like there are a couple of requests that are being sent to all, and what is inserted in the destination address is this broadcast address. So and there, that's the broadcast address. The last in the range of the IP version addresses in a given network, we call that as the broadcast address. Okay, broadcast. So those that are in the middle, those are the host addresses. Okay, this is very important because um, network address and broadcast, these are addresses that cannot be assigned to end devices. Okay, there no, you cannot assign it to end devices. Also interfaces of routers. Okay, let's also add that here, yung mga routers interface. Okay, I think better network devices na lang. Network devices interface, interface. Okay? So there. Usually, again, the network address, that this is the first in the range, right? The first in the range. And then by definition, we define this as the if we would know if that is a network address is if all host bits are zeros. Okay, again, this is in in binary. If it is zeros, if all host bits are zeros, that is a uh, network address. While broadcast is if all host bits are ones. Okay, that's how we define a broadcast. And if it is not a network or a broadcast, then that is a host address. Okay, that's how it is. R1. Okay, I'm good. So, again, the broadcast is the last in the range. Again, take note that this is the last in the range. Let us have an example. I like this one, ano. Let's try this first. Let's say, uh, let's say I will assign a 10.0 here. Okay? If you notice, if I click this, it says invalid. So, the packet tracer can detect if it is a network address. Okay, so let's say we try 192.168.10.255. This is the one that I have in the Excel, di ba? And 10.255, we said that that is a broadcast, right? That's the last in the range. You know, 10.255. If you notice, there, invalid, nag-invalid siya. So, uh, what you are to assign in your end devices should be a network, it should be host addresses. Okay, again, host addresses. So let me go back here. Let's have some example. Say I have an IP address of say uh, 193.10.10.6. So is this a network address, host address, or broadcast? So how do we answer? First, we need to know the class. Okay, So how do we again know the class? We look at the first number. This is a 193, and 193 base here is under class C, right? So, and then the arrangement is slash 24. The host part is just the last number, right? So if it is 0 in bits, that's a network. If it 1 in bits, all ones, that's a host part, a broadcast. So in this case, it's a 6. It's obvious that this is not a network nor a broadcast. Therefore, this is a host address. Okay? Let's have another example. Say, I have a 10.0.0.0. Okay? So what class is this? Look at the class. 10 is under A, and A is network that host that host that host. Okay? I'll have some space for us to for you to have a much better look on how I answer. So, uh, hmm, wait. I'll just have it here. Okay, so example, I have 10.0.0.0. So this is the IP ad. So again, this is a class A. And then take note, you have a network, host, host, and host. Right? If you notice, yung host part, the host part I have here, they are all zeros, right? They are all zeros. If you notice, di ba? All zeros siya. Okay? So, it observe the rule here in the network, right? That all host bits, this one host bits, they are all zeros. So, therefore, this is a network address. Okay? There. So, let's say I have another example here. Say 172.17.10. Sorry, 172 say dot 17.10.0. Okay? So let's take a look. What class is this? 172. 172 is under B. Okay? It's under class B. So, in class B, the arrangement is this is a network, network, host, host. Right? So, again, make it in center. Network, network, host, host. We look at the host part. Our condition should be all host bits should be zeros. This is a 0, but if you notice this one is not 0, right? It's 10. And in binary, 10 is 1010. So it's not all zeros, right? It's not all zeros. Okay? It's not all zeros. So it did not meet the network address. Of course, it's not a broadcast because it's not all ones. Therefore, since this is not a network address nor a broadcast, so therefore that is a host address. Okay? That's how it is. Then last, say I have 192. Ah, I'll have some space here. So example, let's say I have 192 dot 168 dot 10 dot ay, let's have another pala. Say I have 172 again. 172.30.255.255. Okay? So again, what class is this? This is 172, just similar to this one. So that is a class B. So with class B, that's the arrangement. Network, network, host, host. Okay? Network, network, host, host. And um, uh, we look at the host part. It's 255. 255 in binary is 8 ones, right? 1, 2, 3, 4, 5, 6, 7, 8. This one is 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. So it meets the condition of the broadcast, right? That all host bits, these are host bits, network na yon, uh, are ones, right? All host bits are ones. There, oh, all ones. So therefore, this is a broadcast address. Okay, there. So I am done. Save. No, don't need to save. So I am done. Okay. Um, I hope this is informative. You will have more exercises on this because I will let you answer the workbook. This one, right? Defining the class, yung network address, the host address, the default subnet mask, and then there. Okay. So, uh, this ends my discussion in the IPv4. and thank you for listening.